All right, for the last one, this is also an alternating series, and you can apply the alternating series test if you want to. So that's ln n over n squared for an, and you show two items. So the limit has to be 0, but this is infinity over infinity. So that's a good application of the L'Hopital's rule. The derivative of ln n is 1 over n, and the bottom's derivative is 2n. So this is essentially equal to 1 over 2n squared. And this goes to 0. It's good. First condition, check mark for the alternating series test, right? Second condition, you have to prove that an plus 1 is less than or equal to an, or in general, you have to prove that an is not increasing. Okay. So going in this direction is harder. So there was an alternate way to prove that an is decreasing. So you sort of convert that into the f form. So you just create a function like ln x over x squared, and then you look at the first derivative. And I did it for you here. Just you can pause the video and check the details here. But if you look at f prime of x, this comes with the form like this, and obviously x's are greater than or equal to 1. Okay. So as I record this video, by the way, there may be some thunderstorms going on outside, so I'm sorry for the noise, but don't freak out. All right. So since x's are greater or equal to 1, especially this one here, that 1 over 2 minus ln x is going to be negative for x is greater than some finite number, but it's going to be negative, okay? So either starting from 2, you can check all different cases here, but I think even x greater than or equal to 3 would work fine. So any x greater than or equal to 3 will make f prime negative. So that means f is a decreasing function, so that implies that f is a decreasing function. So an is for n is greater than or equal to 3. Okay, so that's good news. It's a decreasing sequence. So the second condition check marked. Okay, we said n is greater than or equal to 3, but it just doesn't matter. N doesn't start from 1 because in the alternating series n starts from 1, so it's like a couple of terms disregarded, but you can sort of like, if you prove that the sum starting from 3 is convergent, then adding a couple of other terms to that is not going to change the deal. So it's still convergent. Okay, and by the alternating series test. Okay, alternating series test, it's convergent. All right. I think we took care of all of the series, but to give you some heads up, in the future, please use this guidelines because it does tell you exactly with what order you should go to find the best test for you and for the given infinite series. You want the shortest way, obviously, to go, the less tedious way to go to prove convergence or divergence. So I would use these guidelines for every given infinite series, especially in the question statement. There is no, especially like you start a problem in the question statement, it says like prove or disprove that the series is convergent. Well, there's no test specified, so when there's no test specified, this is the best guidelines for you to follow. All right, thanks for watching. I'll see you in another video. Bye.